Okay, so LCD interfacing. I thought I'd just record a video because it's hard to get a hold of you. So how does this work? So when you sleep and like when you wake up in the morning, you open your eyes first, then you like remove the dust in the corner of your eyes. You sit up, you stretch around, you yawn a bit, etc., etc. So the LCD also does something similar, and that is basically the initialization of the LCD. So um, before you can like get up and do work, you have to like do all of this, right? Similarly, the LCD also has to do that. So in the code, there are five numbers which you really need to remember: 38, 0E, 01, 06, 84. There's a table over here with like what each of them means. 38 means use two lines in the 5 cross 7 matrix. What that means is, so if you've seen these LCDs in your lab, which I'm sure you have, it's something like that, right? And there's like this and like that. Basically, that means like two, both of these lines, and each of them is like mini 5 cross 7 matrix. That's what you want it to use when you initialize it. Secondly, 0E, display on, cursor blinking. I think this is supposed to be on. I think this might be a typo, but yeah. So when you switch it on, oh, sorry, I'm a bit sick. When you switch it on, you need the display to be on and the cursor should be blinking. Well, that's pretty self-explanatory. 01, clear screen. Any past information which is there on the screen, it won't be, but just in case, we clear it. Increment cursor. Increment cursor as in when you type, the cursor should go one like step to the right. That's what it basically means. And wait, there's also one more which I forgot. 83, yeah. So basically how it works is you see when you see this in this thing, each of these positions has like, so it starts from 80 or 81. So if this, like, assume this is 80, this would be 81, this would be 82, and so on and so forth. So that's what you're basically telling. I don't know what's the starting one, but yeah, that's what it basically means. So let's look at the code. So when one more thing, there's a reset pin, a read write pin, and an enable pin, and data pins. So data pins are the pins through which 8-bit data gets transferred. Reset pin, pretty self-explanatory, just reset it. Read write, to write or read data from the LCD. E pin, enable pin, to enable the LCD. So that's pretty obvious. So in your question, they'll always give you what, like which pins are connected where. So here you can see port 1.0 to port 1.7, D0 to D7, port 2.0 to RS, 2.1 to read write, port 2.2 to enable. So you need to keep in mind all of this. This is important. Like when you get the question, look at all of this. This is important. So then you just start normally. So now you can't directly send 38 to the LCD. You have to send it through A. But even if you send it through A, what is the LCD going to do with 38? It needs to know what the 38 stands for, right? So that's where there is a subroutine called the command write subroutine. You can name it whatever you want, obviously. So once 38 moves to A, what you do is you go to the command write subroutine, where if you see what happens is, so now we know that the data pins are P1, port 1 basically, all of port 1 are the data pins. So if you look at this command write subroutine, you can see from A it's going to port 1. And what is port 1? The data pin. So the data is going to 38H, the number, the value is going to the LCD. So now, once it goes to the LCD, for the LCD to understand if this 38 value which you're giving it is like a data value or if it's a command value. A command value is basically an instruction to the LCD. A data value is basically what the LCD like shows. Like if I want to print hi, H and I are the data values, but this is a command value. So basically what we're doing here is after the data goes to port 1, first you set your reset to 0. This will let the LCD know that, okay, this is a command value and it's not a data value. You set your read write to 0 for write. That'll let the LCD know that you are giving data to it. And then you should send a high to low pulse. So high to low. That's why you're setting this bit. Like look, port 2.2 is connected to the enable pin, right? So if I set it, where is the, okay. If I, what the, yeah, if I set bit that, it's a high value. I'm calling some delay. So the high value sustained for a tiny bit. And then I'm clearing that value. So it's again getting low. So that's the high to low pulse which you need. Now, once that is done, the 38 value has gone to the LCD. So now the LCD knows that I'm supposed to be using both the lines with the 5 cross 7 matrix. The LCD is aware of that. Next, I need to tell the LCD that you have to switch the display on and keep the cursor blinking. So that's why you call some delay after that, and then you move 0E. And then again you call the command right. So now 0E is stored in A. Earlier 38 was stored in A, that's why we got this 5 cross 7 matrix 2 lines. Now that 0 is stored in A, if I again go to the command right subroutine, it's going to send 0E, right? It's going to do it the same way. And then the LCD knows that it's supposed to switch the display on, keep the cursor blinking. Similarly, you clear the LCD with 0, 1. You tell the LCD that like as and when I send data to you, once again, keep in mind, all of this is just command instructions. As and when I send data to you, you're supposed to increment to the right side, move the cursor to the right side. And finally, line 1, position 4. Start from there. Now, once all of that is done, your LCD is ready to project whatever you want. So now, what does the question say? We have to print N and O on the LCD. So let's look at that. If you come here, you you see that now into A, I'm moving the letter N. Keep in mind, since this is not a value, this is just data, we're using the quotes. So now A has the letter N inside it. Now we'll call a separate subroutine called the data write subroutine. So if you look at the data write subroutine, it's very similar to the command write subroutine. Now A has the data, the letter N that is, and that needs to go to the LCD. Like we saw earlier, the port 1 is connected to the data pins of the LCD. So once we come back down, once we come back down here, the letter N is going to the LCD. Now the only difference between the command write and the data write is, remember we set RS to 0 for command. Here we set RS as 1. Everything else is 0. You're still writing data, that's why the read write is 0. And you still need the high to low pulse. That's why we're doing that. And obviously we have the delay and the return statement in both of them is common. So if you see, the only difference is in the set bit and the clear bit. Now once this is done, the LCD is going to have the letter N. Now once that is done, I need to have the letter O. Same thing, call some delay, move the letter O to A, go to data write, where we'll see that the letter O is going to be going into port 1. Once that is done, we are setting it again because we need the LCD to understand that this is data and not a command. We clear this for the write operation, and we have the high to low pulse as always. Once that is done, your LCD's output is going to be NO. Now, once that is done, you're in this statement. And again, let's jump again. So you're just going to stay here forever. That's an infinite loop. You can also write N over here, but write whatever, like if your faculty is giving you a PDF with this, just write that, because it's just to be on the safer side. Now let's look. Now we saw this A call delay being called multiple times. What is the delay thing? Let's have a look at it. So this is a longer delay subroutine. Normally you don't have it this long, but since I guess we need this for LCDs. So once you call the delay, it's going to come to this statement. And it's going to move 50 into the register R3. R3 is a register where you can store values like A. So now this is going to have the value 50. After that, you'll go to the next line. So keep in mind, every time you use A call, it's going to go to the subroutine, and the moment it sees the letters R, E, T, it will go right back to the next line. So suppose if I see A call delay over here, it's going to come here. But if I wrote RET, he would go to clear P2.2 after finishing the statement. Again, it'll go back to clear P2.2 after finishing the statement in the variable define. Anyways, so now R3 has the value 50. Next, R4 has the value 255. Now, the next line says DJNZ R4, comma here. Decrement jump if not 0. Decrement 255 would become 254. Jump if not 0. Is 254 0? No, it's not 0. So where am I supposed to jump? Here. Again, decrement, jump if not 0. Decrement. This will become 253. Again, jump if not 0. Here. Where am I supposed to jump? Again, stay there. So this is going to keep happening till the value of R4 becomes 0. Once it becomes 0, because see, jump if not 0. 0 is 0, so it's not going to jump and come to the next statement. Where you see it says decrement, jump if not 0, R3 here too. What is R3? 50. 50 is going to become 49. Here too. Is 49 0? No. So jump to here too. Again, put 255 in R4. Then again, it's going to count down from 255 all the way to 0. Then it'll come here. Then this will 49 will become 48. Then again, it's going to jump over here. After it jumps here, this is going to happen. R4 is going to get 255. That 255 will again count down to 0. After that, it'll make this 40, it'll come here. It'll make that 48, 47. And this is going to happen a total number of times. Basically, the total number of counts which can be which will happen in this loop can be defined as 50 into 255, right? Because for each value it's decrementing, this thing is happening 255 times. So 50 into 255, that's the total number of times this is going to happen. All right, they give the end statement here, so you don't have to define your end statement there. But yeah, that's how this works. Watch this again if you have any doubt. Let's look at another program.